So for this video, we're going to be using unicorns and assuming they are eukaryotic diploid organisms. Our three loci we're going to look at is horn length, tail texture, and fur color, each with one dominant and one recessive allele. This is our genetic map that we're going to be using as an example, and our coefficient of confidence value is 0.97. So for this experiment, we're going to first cross a pure breeding longhorn curly-tailed white unicorn with a pure breeding short-horn straight-tailed pink unicorn, and using our coefficient of confidence value of 0.97. So for our parental zero generation, we're going to perform the cross just mentioned, and this can look two different ways. It can be shown in a fractional format like this or on chromosomes, but both will show pure breeding big H, big T, little f crossed with a little h, little t, big F. So this will result in this genetic map just shown, and our F1 generation will come out with longhorn curly-tailed pink fur, meaning they're all heterozygotes showing the dominant phenotype. And their genetic map will look like this. So next we're going to take this F1 generation, and to determine linkage, we're going to cross it with a homozygous recessive individual, which will be a short-horned, straight-tailed, white-furred unicorn. So this cross will look like this, shown on chromosomes, with our heterozygous unicorn crossed with a homozygous recessive unicorn, and the probability of gamete types as a result of this test cross are shown below. So the two events we're going to discuss in detail are our double crossover and our single crossover at region 1. So for double crossovers, you find this amount by multiplying the region 1 value by the region 2 value by the coefficient of confidence. So for this example, it will be 0.11 times 0.10 times 0.97, yielding 0.01067. Now this is the event probability, but to find the gamete probability for both big H, little t, little f, and little h, big T, big F, we're going to have to multiply this event probability value by 1/2 for each gamete. And this, as shown here, will yield 0.005335, which is about 0.5%. So that's our double crossover gamete probability. So for our single crossover at region 1, it's going to be multiplied and calculated a little differently, taking the region 1 value minus the double crossover event probability. So for our example, it will be 0.11 minus 0.01067, yielding 0.09933. So just as before, to find our gamete probability, we're going to have to multiply this value by 1/2. So for little h, big T, little f, it'll be 1/2 times 0.09933, yielding 0.04967. And the same for big H, little t, big F. So this is about a 4% gamete probability. And for the single crossover event 2 and no crossover events, they're calculated similar ways, just with different values. And this, as I've shown, is our genetic map that we use to get this information.